So in our last class we have evaluated the infinite integral, improper integral sin x by x, this one, by considering some indented contour because the function was not analytic at 0. So therefore we have considered the indented contour. Indented contour means there are some breakpoints. So this was from minus r to minus rho. This is the straight line. This is the point origin, and this is real axis, imaginary axis. This was your semicircle 0. This is again this is say L1, and this is L2, straight line L2, which is extending from rho to r, and this is your CR. So we have considered the indented contour starting from here, then this semicircle, then this straight line, then this positively oriented semicircle. Okay, and because we have considered fz equal to sin z by z, which is not analytic at z equal to 0, so this 0 was outside this simple closed contour, positively oriented, and and we used Cauchy residue theorem to evaluate this integral, and we have found that this is pi by 2. Now we consider another type of improper integral. For example, let us say we want to evaluate, say, log x squared and x squared plus 1 dx. Okay, so in this case we consider fz equal to, so it is log x, so therefore we consider the complex log z function, and that is squared and z squared plus 1. So now you see that the singular points of fz is given by z square plus 1 equal to 0, and that implies z equal to plus minus I. So, and apart from this, there also, because log z is multivalued function, so we need to consider a branch of log z, and we consider the branch of log z, branch cut, in such a way that log z is analytic in this contour. Okay, in this contour, but there may be one singular point here. Okay, so and then which singular point is here? This one is I, because z equal to plus I and minus I are singular points of 1 by z square plus 1. For this is coming from the denominator, and for numerator also we have singular points, because log z is not analytic everywhere. Okay, so it has a branch. So let us consider the branch, so that the branch cut does not intersect this contour. So which branch cut will take? What is the special branch cut? So this can be the branch cut. That means the negative imaginary axis. So therefore we consider the branch log of z. How we define this is ln of real log of modulus of z. So let us see, this is r, and plus I of the argument of z, and that is theta, and the branch is that your r is strictly greater than 0, and your theta is this straight line. Okay, so that means the argument is from starting from here to here, except this ray. So therefore I have what? Because this angle is pi by 2, so theta varies from minus pi by 2 to 3 pi by 2. And because I am not writing this is less than equal to and this is less than equal to, we are not writing, so we are omitting the ray theta equal to minus pi by 2. That means this is not included, theta, this is not included in the branch. Okay, so this is your branch, and we know that this is analytic everywhere in this region. Okay, so we consider this log z. So now you see that the function fz is equal to, so the function is log z squared by z squared plus 1 is analytic on and inside where? Inside this one, L1 plus 0 plus L2 plus CR plus CR. Okay, so this is analytic except what is the point where it is not analytic? I. Except Z equal to I, where what is L1? L1 is from minus R to minus rho. So we consider minus L1, which is minus rho to minus R. Okay, where so we have minus L1. What is the parametric form? This is nothing but Z equal to, let us write in polar form so that I can evaluate log Z. So this is R E, okay, R exponential I, then I, what is the argument of this line? Pi. Okay, so I pi, right? And R varies from rho to R, because when R equal to rho, so you see that it is rho E I pi, and that is minus rho, so it is minus rho. And when R equal to capital R, so it is capital R e to the power I pi, and that is minus R. Okay, so minus R, and that is this one. But we are considering minus L1, so it is minus rho to minus R, and we have L1 is minus R to minus rho, so minus L1 is this. Similarly, what is L2? L2 is direct because it is rho to R, so it is not Z equal to R E. What is the argument of this straight line? This is on the positive real axis, so argument is I 0, argument is 0. So R is less than R less than rho, and this is nothing but actually, this is actually equal to just R, right? So this is the parametric form of L2. Okay. Similarly, 0. So what is 0? 0 is Z theta equal to, the radius is rho e to the power I theta, okay, and minus 0 actually. So this is from this to this one, and 0 is from minus rho to rho. So therefore this theta is 0 to pi. So when theta equal to 0, so it is rho, and when theta equal to pi, this is minus rho. So rho to minus rho, but it is 0, so therefore we have minus of 0, all right, the other side. So similarly, we have CR is Z theta. What is the radius of CR? CR is R E I theta, and this is theta less than equal to 0 and less than pi. With, now we have this I should be in between that, so your rho must be what? Rho must be this must be less than, this rho must be so rho must be less than this one. Okay, rho is less than R. Okay, so next slide.